complex number Z1 is shown there on the argan diagram, and we need to find out, write down the value of A and the value of B if Z1 equals A plus BI. So looking at Z1, well, it's A is there, this is the real part, so 1, 2, 3, so A is 3, and B is the imaginary piece, the y-axis, one step up. That's going to be 1. Okay, the next then, the image of Z1 on the reflection in the real axis is Z2 on the reflection in the real axis. So this is the real axis. So if we reflect through here, that's one step down to here and another step. That there is going to be Z2. Write down the value of C and the value of D, where Z2 equals C plus DI. Same idea. The real bit is first there, so it's going to be 3 hops out from the origin, 1, 2, 3. And D then is going to be our Y bit, up or down, and in this case we're going down. We're going down one jump. We're going down the stairs one step from the origin. So D is going to be -1. And then we're moving on. Part B, part 1 of part B, the angle theta is formed by joining Z1 to 0 plus 0i. That's the origin there. So by joining Z1 to 0 plus 0i. So I'll just grab a ruler here and let's do that. Now pencil would be better, but I want to make it clearer maybe. So I'm doing it in pen. So Z1 is now joined to 0 plus 0i, and then we're joining 0 plus 0i to Z2. And the angle formed there then is theta. So let's be careful there. The angle theta is this angle in here, marked in red. Theta. Okay. So that's the angle we're looking for. And they're saying find cos theta correct to 1 decimal place. Well, the clue there is they're looking for cos theta. And if we look up on our logbooks, page 16 there, this is our cosine rule for a triangle. Right, where A, B and C are the lengths of sides, and A is an unknown angle. So if we apply that to our triangle here, okay, we apply that to our triangle here, we know this side here has a length of 2, because we're going 1 and another step down, that's a length of 2. And do we know the lengths of the other sides? Well, the other sides we can figure them out using Pythagoras Theorem, because we know that this here is a length of 3, this center line here if you like, 3. So if I sketch that out, I have 2 and I have 3 here, that's a right angle. So by Pythagoras Theorem, the hypotenuse here opposite the right angle, h squared equals 2 squared plus 3 squared, that should be 1 actually. 1 squared plus 3 squared. So h, getting the square root of both sides, h equals 1 squared plus 3 squared. H equals the square root of 1 plus 9. So h equals root 10. So this slanty bit here, if you like, the hypotenuse, that's got a length of root 10. And this is a similar triangle hanging down here from the real axis, so that's going to have a length of root 10. And this one has a length of root 10. So now we know the other sides of our triangle. So we don't know this angle, but we know the other 3 sides, and that's a recipe for using the cosine rule. So I could do a mini sketch here. Right, this is 2, this is root 10, this is root 10. And we're asked for the cosine of this angle here, theta. Now, we can call this side, this unknown angle, is like, that's equivalent to our A, angle A on this drawing here on our logbook. So we've A squared equals B squared plus C squared minus 2BC cos A. Right, so A is going to be 2. B can be either of these, doesn't matter. C is the other one, So b is root 10, c is root 10. 2 times bc will be 2 times root 10 times root 10. So we'll fill that out, and we'll have 2 squared equals root 10 squared plus root 10 squared minus 2 times root 10 times root 10 times cosine of a. And a, we call it theta, right? So it doesn't matter whether you use theta or a. And then we'll just tidy this up. So we'll have 4 equals, this guy here, root 10 times root 10, is just going to be 10. Similar pattern here. Minus 2 times root 10 times root 10. Well, you can put that in the calculator if you like and check it out, but you'll come out with 2 times 10 times cos theta. And now it's just a matter of tidying up. So we have 4 equals 20 minus 20 times cos theta. And now I'm going to subtract 20 from both sides to get rid of this 20 here. And I end up with minus 16 equals minus 20 cos theta. Now I'll divide both sides by minus 20. And I have minus 16 over minus 20 equals cos theta. And we can simplify that further and say that cos theta, the minuses cancel out, 4 into 16 goes 4 times, and 4 into 20 goes 5 times. Cos theta equals 4 over 5. And that's our answer. Part 2 then, what's going on here, show that this times this here times cos theta equals AC plus BD. Now we have AC and BD from above, up here, right? Now this here means the modulus of Z1 times the modulus of Z2. The modulus is the distance. This here means the distance of the complex number, from the complex number to the origin. For Z1 then, that's going to be root 10. So this is going to be root 10 multiplied by root 10, because Z2 is also a distance of root 10 from the origin. We're going to be multiplying it by cos theta, which we figured out to be 4 over 5. And we're going to be figuring, just going to see if this actually equals AC. A times C is 3 times 3. 3 threes comes to 9, plus BD. BD is 1 times minus 1. 1 times minus 1 is minus 1. So it's going to be plus minus 1. So that gives us 9 plus minus 1 on the right hand side, which comes to 8. And on the other side we're going to root 10 times root 10, which is 10 multiplied by 4 over 5. Okay, and that's like multiplying. You can bang it into the calculator, or you can turn that into a fraction. Multiply the tops. You 10 fours are 40, and 1 times 5 is 5. And 40 divided by 5 is 8. So we're happy. And we've shown that the modulus of this multiplied by the modulus of the other number times cos theta equals this on the right hand side.